Hello everyone, welcome to Power Electronics and Instrumentation class. Today we are going to deal with the principles of PWM switching or the different types of PWM techniques that are used in inverters. Now, the need for PWM techniques in inverters we can understand what is the need for PWM techniques in the inverters. Now, in order to know the need of the PWM techniques, we need to know what are harmonics. First and foremost, we have to know what are harmonics. Now, what does an inverter do? An inverter is basically converting your DC supply into an AC supply or an alternating supply. And it is always desirable that your alternating supply should be sinusoidal in nature. Why? Only if it is having a sinusoidal nature, only then your devices will be operating in a proper manner. Now, if you take our normal stepped inverter, if you take a normal inverter, your inverter is going to give you output which is having a square waveform or square shape. And you can see directly by comparison that it is just you have a positive cycle and a negative cycle, but there is a problem. The shape is not at all sinusoidal. Now, because of this difference in the shape, there are your harmonics are going to get introduced within your particular circuit, and this will lead to problems in the operation of your devices. It can cause humming noises or any other particular drawbacks while operating. Now, so it is always desirable that you have to remove the harmonics. Only the fundamental harmonics or the fundamental frequency is desirable. And if you take in the case of harmonics, always the even harmonics are not present or it is not considered. Only the odd harmonics are giving the undesirable effects. And among the odd harmonics, the higher order harmonics are okay. Even if there are higher order harmonics, like the third, fifth and seventh, among the 3, 5 and 7, the third and the fifth are always the most dangerous because it is very difficult to remove them. But the higher order harmonics, you can filter them out using any type of filter circuits easily. In an easy manner, it can be removed. So that's also one of the other points that we need to remember. Now, we have already mentioned the output of the inverters are square wave and they contain a lot of harmonics. And the PWM techniques, they help us to remove the particular amount of harmonics from the output. And the remaining higher order harmonics can be removed by using any filter circuits. Now, you have three different PWM techniques. You have the single pulse modulation, multiple pulse modulation and sinusoidal pulse modulation. These are the three of the techniques that we are going to discuss in this particular video. So first let's move on to the single pulse modulation. Now, as the name suggests, single pulse modulation means in your output you will be having only one pulse. Okay. Now, in order to get this one pulse, okay, if you're taking your particular output waveform, you'll be having one pulse in the positive cycle and one pulse in the negative cycle. How are you getting this one pulse? You can vary the width of the pulse according to your width. Okay. Now, how are you obtaining this particular pulse? You are going to compare two different signals. One is going to be a rectangular signal and the other is going to be one is going to be a triangular signal and the other is going to be a rectangular signal. Okay, I think instead of me drawing over here, I think it will not be quite beautiful. I have already provided a figure. So we can just look at the figure over here. You can see over here you are having your triangular waveform and you are having your reference signal. Okay, you have your reference rectangular signal. Now, you're going to compare these two signals, and whenever the reference signal is greater than the carrier signal, whenever the reference signal is greater than the carrier signal, at that time your switches will be triggered and you will be getting the output. And if the reference is less than the carrier, you can see that during the first particular time period over here, in this particular time period, your reference signal is the rectangular waveform. And the rectangular waveform is lower than that of your carrier. So in that case, you can see that your output is 0. And then when it comes to this particular portion, you can see your triangular waveform has come downwards. So your rectangular signal is greater. So in this particular case, you are going to get the output. And similarly, you're going to get it in the negative cycle. You can see over here, this negative value is greater than this particular value. Okay. And then you are getting the particular output in the negative direction. Okay, so this is the single pulse modulation, and you can see that your waveform is symmetrical about pi by 2 and 3 pi by 2. Okay, your waveform will be symmetrical about these two values. So this is the single pulse modulation. It's quite easy, right? Next, we are going to study the multiple pulse modulation. Now, the multiple pulse modulation, it is similar to that of your single pulse modulation, but the number of pulses in one half cycle will be greater. And the number of half cycles depends on the number of triangular waveforms present in one particular cycle. So here you can see that the number of triangles have been increased and accordingly comparison is taking place and you are getting more number of pulses. What is the advantage of increasing the number of pulses? If the number of pulses are increased, the harmonics can be, the higher order harmonics will be present more within the circuit and lower order harmonics can be avoided. This will help us to eliminate the lower order harmonics, and you can use any kind of filter circuit and remove the higher order harmonics more easily. This is very similar to your single pulse modulation. So I think the waveform is self-explanatory. Again, your reference signal is the square waveform and your carrier signal is the triangular waveform. Now, let's move on to the last type of modulation, that is the sinusoidal pulse modulation. Now, in the sinusoidal pulse modulation, if you are comparing it with the multiple pulse modulation, the number of pulses are more, but the width of the pulses is varying. You can see over here in the multiple pulse modulation, you have the width is the same for all of the pulses. But for the sinusoidal pulse modulation, the width of the pulses will be varying and therefore it will give a shape which is more sinusoidal in nature. Okay, so let's just see over here. Here you can see that here in this particular case, the triangular waveform is the carrier and you're going to take the reference as the sinusoidal waveform. And the output will be positive whenever the sinusoidal waveform is greater. So you can just take this particular dotted portion over here. You can see that over here the sine wave is greater, that is why your output is high. And if you check over here, your output is greater at this particular portion and that is why you are actually there's a small mismatch in, there's a small shift you can see over here, that is why the graph has shifted a bit towards the other side. Okay, so whenever your sinusoidal waveform is greater than the triangular waveform, at that time you'll be getting the output and you can just see the output how it is, how the width is varying. If you take the average of this particular value, you can see that it will be approximately a sinusoidal waveform. And in such waveforms, the harmonics will be the least. Not the order of the harmonics will be lower. Now, as the final topic, you have to study about the modulation index. The modulation index is the ratio of the reference voltage to the carrier voltage. Now, the modulation index will give you according to the modulation, by controlling the modulation index, you can control the harmonic content present within the particular output waveform. If the modulation index is less than 1, the amount of or the order of the harmonics will be greater. You will be having higher order harmonics. And the higher order harmonics, as I already mentioned, it is easier to filter it out. Whereas the lower order harmonics, they can be reduced if you are having the modulation index as less than 1. If your modulation index is greater than 1, it's going to be a problem because the lower order harmonics will appear in the circuit and these are not easy to remove from the particular circuit. So this is all about the different types of PWM switching schemes and relating to the particular inverters. I hope the class was clear. It's quite a simple topic. you have three different types of modulation schemes which we have to study over here. The first one was the single pulse modulation, where you have the reference as the square waveform and your carrier was the triangular waveform. You can see over here the triangle, it's not starting like this. It's starting from the peak value. It's starting like this. And then you have your square waveform. And whenever the reference is greater, only then you'll be getting the output. In all of the cases, you'll be getting the output only if the reference is greater. But in the single pulse modulation, your square waveform is the reference. In multiple pulse also, your square waveform is the reference. But in sinusoidal waveform, your sine wave is the reference. Okay, so that's the only difference. Or in other words, the carrier signal in the first two, that is single pulse and multiple pulse, the carrier signal is the same, it's a triangular. Sorry, in all of the cases, the carrier is the triangular waveform. So this is your multiple pulse waveforms. You can see over here that whenever the reference is greater, you are going to get the output. Okay, the number of pulses are higher, but the width of the pulses are the same. And if you're taking the sinusoidal pulse width modulation, you can see again the carrier is your triangular waveform and your reference is a sinusoidal waveform, but you have the width is varying according to our requirement. Okay, so these are the three different types of modulation, PWM modulation techniques. There are also other methods, but these are the three which are most most important. Okay, so thank you for watching the video. Please stay tuned for more videos. Have a good day.